Hello everyone, so today in this video we're going to be looking at this question, kill Demodogs. Okay, maths question. So what basically the question is saying, let me take the test case and explain it to you guys. Okay, so in question you have given an integer n. Wait a minute, my camera is blurring. Okay, so in this question you have given an n, and what is n? N is basically the size of, size of the grid. Let's suppose it is 3. So let's suppose your size of the grid is going to be 3. So this is going to be a grid. Okay, so what basically the question is saying, that there is a girl named Levin and there is a boy named Mike. So Levin is standing right here in first cell and Mike is standing right in the last cell. Okay, so this girl has to reach to this boy Mike, and in between, in these all the cells contain some Demodogs. Okay, and what are the number of Demodogs in each cell? It is like I multiplied by j. Okay, so it is basically the index of that cell. So these are the number of Demodogs present in these cells. Okay, so the girl is going to kill these number of Demodogs in each cell. Okay, so in this question you can see that 11 has many ways to reach Mike. Let's suppose she can go through this path and reach to the Mike. She can go from this path to and reach to the Mike, and or she can take this zigzag path. Okay, and one more thing is here is that the 11 can only move to right or to down. Okay, so let me make an observation by drawing two examples. Like let's suppose first of all we have a grid 3 cross 3, and another grid we have 4 cross 4 grid. So we can just look out some observation from these grids. So what are the index going to be of this grid? So first of all, it is 1 1, it is 1 2, it is 3 2, and 3 3. Okay, so these are the index of these these grids. So what is going to be the optimal way to maximize the kills is that you just move in this zigzag form. Okay, so if 11 is going to move in this zigzag form or in this form, so it is going to be the most optimal way to maximize the kill by 11 while reaching to Mike. Okay, so what we can observe here is that we are just going to take two diagonals. So first of all, first diagonal is going to be this diagonal, and another diagonal is going to be this diagonal. Okay, or you can also take this diagonal, but taking the middle diagonal is necessary. It is must to take the middle diagonal, and after taking middle diagonal you can take any of this diagonal, so in this way you can actually maximize your killing to Demodogs. Okay, so just look out, we can make a formula right here that you can see that this in this you have at max n cell, if your grid is of 4, so you have 4 cells in this diagonal, but in this diagonal or in this diagonal you have n minus 1 cells. See, if the grid is of size 4, so you have 1 2 3 or 1 2 3. Okay, but in this 1 2 3 4, so what basically I'm saying that this is going up to n and this is going up to n minus 1. Okay, so let me write the index of the cells through which 11 is going to reach Mike. Okay, so what we have figured out from here, that the optimal way is that the in first C is going to move this and this. Okay, so let me write the index. So first is equal to 1 into 1, then 1 into 2, then C is going to move here, right? So 2 into 2, then C is going to move here, right, which is 2 cross 3, then C is going to move right here. Okay, so it is 3 cross 3. So from this we can make a formula out here, is that 1 cross 1, 2 cross 2, 3 cross 3. This is basically what is this? This is actually this is actually a square. 1 square plus 2 square plus 3 square up to n square, and you know that what is the sum of the natural square number, is that it is n square, summation of n square, and n I equals to 1, it is going up to n. Okay, I is going till n. So you have sorted out this thing. Now what is the remaining thing? The remaining thing is like this, these two. So we can see that if it is I, then it is I plus 2, I plus 1. Okay, if it is I, then this 3 is I plus 1. Let's suppose this I is 2, so this 3 is 2 plus 1 equals to 3. So we can do here is that I cross I plus 1. And what is this? This is like this diagonal, this diagonal. These two elements are these diagonals. And what is and how many up to these diagonals are going? It is going up to 1 n minus 1 cells. Okay, so we can see, we can write here I from 1 up to n minus 1. So this is actually our formula, and we are going to expand this formula. Okay, so from previous observation we have come through this formula. Okay, so now we're going to expand this formula. So now we know that what is the formula of n square. Okay, summation of n square, its formula is basically n into n plus 1 into 2n plus 1 and by 6. Okay, now what we can write this, we can expand this thing as summation of I square plus summation of I. Okay, and it is going up to n minus 1, and it is also going up to n minus 1. So we can expand this as this. So what we can see is that this is similar to this. So we can write here that n into n plus 1 2n plus 1 upon 6 plus the same thing, right? But you know, like the thing is that it is going up to n, and this thing is going up to n minus 1. So we have to replace n minus 1 with n. So every n is going to replace with n minus 1. So n minus 1, here n minus 1 plus 1, and here 2 n minus 1 plus 1 and upon 6. Okay, now this thing okay, now you know what is this thing. This is just the summation of n natural numbers. So what is the formula of this? Like we have a formula of this is n into n plus 1 by 2. So this is the formula of this thing. Okay, and this is also going up to n minus 1. So in the next step we have to replace this n by n minus 1. So let me solve this equation. It is n plus 1 2n plus 1 upon 6 plus this is something like n minus 1, and this one is going to cancel out. So this is n, this is going to be 2n minus 1 and upon 6. And if we replace these n's with n minus 1, so it is going to n minus 1 plus 1 upon 2. So this minus 1 and this plus 1 is going to cancel out. So what we're going to get, we're going to get these two same terms and this terms. So let me do this thing. N plus 1, this is 2n plus 1 upon 6, this is actually 1. Okay, so now this is n into n minus 1 2n minus 1 upon 6, and this is going to be like n into n minus 1 upon 2. So guys, to save some time, I have skipped some calculation. So after this point we are going to take simply we have just multiplied n values with each others. Okay, and after doing this we have expanded these values. I have multiplied this value with this is just simple calculation. And after that I have taken LCM like 6. Okay, and after taking LCM 6 we are going to continue it further. So in this, now you can see that some of the values are going to cancel, like this n square is going to cancel with this n square, this 2n square with this 2n square, and I guess these are the things which are going to cancel. So we can write the remaining things on the next step, like 2n cube, then this 2n cube plus 2n cube, then we got here 1n, then we got another n here, then we got 3n square minus 3n, okay, upon 6. So now we can add these things. So this is going to become like 4n cube plus n is going to be 2n and minus 3n. So it is going to be 4n cube minus n and plus 3n square upon 6. Okay guys, so this is just, we can arrange that equation as like this equation. Now we can take something common from this equation, like we can take n from this equation. This is n square. So what is going to remain here is 4n minus 1. Now we can take n from this common as well. So it is going to remain 4n minus 1 upon 6. So now you can see that this is the common term. So we are going to extract this term 4n minus 1 and n square plus n upon 6. Now we can expand this term, we can write this term like n into n plus 1 and 4n minus 1 upon 6. So actually guys, this is going to be the formal like final equation in which we are going to get our answer in O1 time complexity, which is the constant time complexity. So just make sure to like there is one more thing. The question is giving that we have to multiply it by 2022. Okay, so we can just multiply it by here 2022, so it's going to get us the value 337. So the final answer is going to be 337 into n plus 1 into 4n minus 1. So this is just going to be the final equation in which we are going to answer. And also mod by mod after every like every sequence. So after n, you just need to mod it by the given value 10 to the power 9 plus 7, and after this you just need to mod this with 10 to the power 9 plus 7, and after this you just need to mod it by 10 to the power 9 plus 7. Okay, so like you are modding this thing because of the like memory, because you cannot store any integer like which is having the size 10 to the power 9, so you can't store like this much value in any integer. Also it is going to multiply by itself. So you can see that if you multiply by 10 into 10 to the power 9 into 10 to the power 9, so it is going to be a very massive number, so you can even store in this like array. So this is basically the question, and the code of the question is available in the description. I have explained every bit of this question, so just make sure to like the video and subscribe to the channel for more videos. Thank you so much guys.